Let's look at this example. I of t equals to 6 cosine 5t minus 40 degree. What is a phasor? Phasor is I. The notation is big I, capitalized I, equals to magnitude, because this is cosine, and the phase minus 40 degree. The unit is still the same. Let's look at this example. V of t equals to minus 4 sine 20t plus 40 degree. Note that there is a negative sign here, and also that's the sign. We want to convert this format into a cosine. We're going to use this formula. So we want to convert minus sine into cosine. Remember omega t here, that's notation of alpha. This is omega t notation of alpha. Same thing here, notation of alpha. This portion is alpha 20t plus 40 degree, and we need to add 90 degree. That equals 4 20t plus 130 degrees. What's the phasor? Phasor is the big V, capitalized V, equals to 4, that's the magnitude, 130 degrees. The unit is volt. Let's look at this question. We know phasor V equals to minus 25, that's the magnitude, and angle 40 degree. What's the time domain expression? So time domain V of t equals to minus 25, that's the magnitude, that's 25, cosine omega t plus 40 degree, that's the phase. If we want to get rid of this minus sign in front of cosine, we can use this formula. Minus cosine alpha, or minus cosine omega t, equals to cosine omega t plus or minus 180 degree. We can choose either plus or minus. Here we choose minus because we want this angle to be less than 180 degree and greater than minus 180 degree. What about the phasor is given in this format? Now this is a rectangular format. So we can do a little reorganization here. We take into J here to break up this bracket. So 12J plus 5. And remember, J squared equals to minus 1. So that's the real part 5, and imaginary part 12J. Now to obtain the time domain expression, we need to obtain the polar form of this complex number. So polar form, we need to obtain the magnitude, and then we obtain the angle. The angle arctangent, 12 divided by 5, that's 67.4 degree. So the magnitude is 13. This is the angle, that's the phase. So what's the time domain? Time domain expression 13 cosine omega t plus 67.4 degree here. Remember that phasor is related with omega already, is implicitly embedded in the phasor. Therefore, phasor domain also referred as frequency domain. Let's look at this example. I1t and I2t is given. How do we use phasor obtain I1t plus I2t? Now in the phasor domain, we need to convert I1 and I2 into the phasor. So the first phasor I1 equals to 430 degree, that's the polar form. Second is 5, that's magnitude, and using the transformation from sine to cosine, we minus 90 degree. So the phasor is 5 minus 110 degree. If we do not want to do this conversion, we memorize this relationship or this table. Vm sine to Vm phi minus 90 degrees. So there's a minus 90 degree phase shift for the waveform of sine. Now we do the addition in phasor domain. So total phasor This is the sum of I1 and I2. We denote it by I. That's first phasor, second phasor. And then we use Euler's formula. This is 4 cosine 30 degree plus j sine 30 degree, and 5 cosine minus 110 degree plus j sine minus 100 degree. Plug it in either using MATLAB or a calculator. We have that's the first portion from this portion here. It's the real part, this real part and imaginary part. And second portion is the real part and imaginary part, and we add them together. That's the real part, and this is the imaginary part. So the phase is minus 57 degree because it's in the fourth quadrant. It's in this quadrant. The magnitude is 3.2. What is I of t? I of t is 3.2 cosine omega t minus 57 degree.